On Friday, we started looking at rationals. And do you guys remember what it means to be rational? It's just another word for starts with an F? Fraction. So today we are going to go through two operations. On Friday, we just simplified rationals. Today we are going to multiply and divide fractions, aka rationals. Do you guys remember what the process is for multiplying fractions? So if you saw like 2/5 times 3/7, how do you multiply fractions? What did you say?
2 times 7, 3 times 5.
Close. When you multiply fractions, you just go straight across. So that means up top, you just do 2 times 3. On the bottom, you just do 5 times 7. And then at the end, you would check, does anything reduce 6/35? No. The nice thing about when you multiply fractions straight across, if you have something like 4/5 times 10/4. When you guys multiply fractions, since it's straight across, you can kind of just think of this as extending the fraction bar, and then you multiply on top, you multiply on bottom. The long way of doing this is, what's 4 times 10? What's 5 times 4? 20. When you reduce, what does that turn into? A 2. But from what we did on Friday, when you guys simplify a fraction, if it has the same thing on top and bottom, what do they do? Cancel. So once you think of it as one big fraction, we have a 4 on top, we have a 4 on the bottom, they cancel. When you look at the 10 and the 5, is there a number that divides both 10 and 5? 5. What's 10 divided by 5? What's 5 divided by 5? So do you see how if you do your reducing, you still end up with that same answer? And that's kind of the process we're going to be going through today. So when we multiply fractions, the key part is that we have to multiply straight across. And since we are going to be doing these with variables and expressions, when we multiply, the main thing is make sure things are factored. And then because you still have to multiply straight across, anything on top reduces with anything on the bottom. You need a note.
Oh no, I would.
Okay. So multiplying rationals is literally the same thing we did on Friday, except for instead of just having like one fraction, it's technically 2, but you can still kind of just like lump it into one big old fraction. All right, so first one. When you guys see this, as long as you are multiplying, you can think of it as just one big old fraction. And then depending on how you want to kind of organize this, lots of different ways of doing it, just make sure you're kind of like neat in your work. I tend to do my like simplifying on the problem. So when I see like a 5 and a 10, the 5 is on top, the 10 is on bottom, those can reduce. The 5 is gone, what's the 10 gonna turn into? A 2. What about the 2 and the 6? Where's the 3 going to be? On top or on bottom? Where the 6 is. So you can divide these. And then your variables. How many y's do we have on top? How many y's do we have on the bottom? We have 5 total. We have a 3 and we have a 2. So when you guys look at these, we have a y on top, and we have 5 y's on the bottom. How many x's do we have on top? 5 total. We have a 3 and then another 2. How many x's do we have on the bottom? What number is left up on top? What number is left on the bottom? 2. So depending on how many steps you want to show here, it's totally up to you guys as long as you're getting the same answer every time. The numbers can't be reduced anymore. The y's, remember the shortcut from last time is you can subtract your exponents. How many y's are going to be left over? So we have 5 on the bottom, 1 on the top. Or how many do we have left over? 4. Subtract your exponents. Are those 4 going to be on top or on bottom? Bottom. There's more on the bottom. Your x's. Subtract your exponents. How many total x's are we going to have left over? 4. 5 minus 1. Are they on top or on bottom? Top. So just make sure that you cancel things out, you reduce them. When you are in your final step, you subtract your exponents. Because there are no plus minus signs, that's why we didn't need to do any factoring there. On the next one, we do have plus minus signs. So remember, when you have plus minus signs, you can't cancel like an x squared with an x squared. Instead, you have to factor everything. We have 4 parts we got to factor. Which of these 4 cannot be factored? The top, bottom, left side, right side. Bottom, or which one? Bottom right. Do you guys agree that can't be factored? So I'm just going to copy it down. Above it, x squared plus x minus 20. Is there a greatest common factor? Nope. So our parentheses have to start with x and x. Do we have same signs or opposite signs? Opposite. How do we get a 20 with a 1? Plus 5 minus 4. Jumping now to the bottom left, is there a greatest common factor of the bottom left? Nope. So x squared has to come from x and x. Do we have same signs or opposite signs? Opposite. How do you get a 5 and a 4? Yeah, plus 5 minus 1. And then the top left. This is kind of the tricky one because looking at it, what's different about the top left than all the others? There is a GCF, and you see how it's kind of written backwards. We always want our highest exponent first. So before we do any factoring, I'm just going to flip this, and we have a negative 3x squared, and we have a positive 3x. Because when we factor things, it's best if everything kind of follows the same order. This one, we want our x squared first. Once you write it that way, find your GCF. What is the GCF here? 3x. And if we start with a negative, do we want to keep the negative or take it out? Take it out. So I'm going to take out a negative 3x out of just this portion right here. That leaves us with an x. And then what's left of positive 3x if you take out a negative 3x? Yeah, minus 1. Once you have everything factored, remember a multiplication problem is literally just multiplying straight across. So you can kind of just think of it as one big fraction. Anything on top can reduce with anything on the bottom. Doesn't matter what side it's on. So what's something that can cancel? X minus 1s. What else can cancel? Yep, your x plus 5s. Anything else that can cancel? The 3x. With this 3x, be careful, because what's going to be left over up top here? Yep, a negative 1 if you want to attach a number to it. So anything on top cancels with anything on the bottom. So up top, we're left with a negative 1 and an x minus 4. Do we have anything left over on the bottom? No. So multiplying is literally just simplifying, except for instead of one fraction, you're going to have 2 that you have to go through all the steps with. The next one, I did not space this out very well, so I'm probably going to work like above on this one. When you don't have a fraction, you want a fraction. So what can you always put on the bottom to make it a fraction? A 1. So think of this as a 1 underneath. And then go through and just start your factoring. Can we factor x plus 3? Nope, so that's stuck. 2x squared minus 128. What's our first step in factoring that one? What's our GCF? A 2. So we're going to take out a 2. Leaves us with an x squared, and then is that 64? When you guys do your factoring, make sure you always factor it as much as you can. So x squared minus 64. What's special about x squared and 64? They're perfect squares. So the bottom left is a 2. X squared comes from x and x. How do we get a minus 64 with nothing left over in the middle? Yeah, plus minus 8. The 1 is stuck on the bottom. We needed that just so we had a fraction and a fraction. And then up top, do we have a GCF? Nope, so we got our 2 parentheses. X squared is x and x. Do we have same signs or opposite signs? Opposite signs. And then how do you get a negative 8 with a positive 7? Yeah, plus 8 minus 1. Once you have it all factored, anything on top can reduce with anything on the bottom because fractions just multiply straight across. So what's something that can cancel? Do we have anything else that's the exact same? No. So once you have it factored, canceled, your final answer, you just write what's left over. So up top, we have an x plus 3 and an x minus 1. On the bottom, what's left over down there? Yeah, 2 and then the x minus 8. That 1 right there isn't doing anything. For this, you don't need to multiply it out. You don't need to like FOIL it back out to get your answer. I would prefer you guys leave it in the factored pieces just because then it's easier for me to see like this is how you broke it down. Last multiplying one. Are there any that are backwards that we should probably write the other way to start? Which one? Bottom left. Again, it's not necessarily needed, but sometimes it's usually more helpful to think of it that way. Because if you think of it that way, what can come out of that expression? If we start with the negative, what should we usually take out? A negative 1. When you guys are checking your answers against my answers, there is a possibility that we do our factoring a little bit differently, but if our answers are the same, that's the main thing. Are there any other GCFs that can be taken out?
Yeah.
Okay, top left, what can we take out? When you guys look at my answers, it's kind of a hodgepodge of work everywhere. Just make sure you can keep track of where you're writing everything. If there's GCFs, I usually write it just right above it. Top right, what's our GCF? Bottom right, what's our GCF? Usually, if you look at a problem, you can tell if there's going to be GCFs. So don't forget about the GCFs. And then jump down and be like, okay, let's finish factoring this. Because looking at top left, we have x and then x squared minus 25. Can we factor x squared minus 25 anymore? Yep, they're both perfect squares. So we have our x in front, x and x. How do we get a minus 25 with nothing in the middle? Yep, plus and minus 5. On the bottom, we have that negative 1, x squared minus 16. Again, do you see how we have perfect squares? So you will have a lot of perfect squares again. X and x, what gives us our 16? The 4s. Top right, how do we factor that guy? The 2 is still there, what gives us our 16? Plus and minus 4 again. And then can we factor bottom right anymore? Nope, not a squared, so that one will just stay as 8x and then x plus 5. The biggest thing about multiplying is just being able to get your factors right, because once you have everything factored, it's just the game of crossing things up. So what's something that is the exact same from top to bottom? X plus 4, x minus 4.
X plus 5.
X plus 5, x plus 5. 2 more. The x's, so these both have an x. And then last thing, what numbers up top? What numbers on the bottom? So the 2 and the 8, the numbers can still reduce like normal numbers. So what number divides both 2 and 8? 2, so that 2 is gone. What's the 8 going to turn into? 4. So up top, we just have x minus 5 left over. On the bottom, negative 4. Because that negative 1 was hanging out in front. The 4 was reduced from the 8. So multiplying fractions, it's literally just simplifying. It's just more pieces. Do you guys have questions on how to multiply? All right, we're doing the other one too today. Back up to the top, dividing. How do you divide rationals / fractions? This one is the trick. You have to something and something. Flip and change it to what? Instead of division, what will it change to? Yep, multiply by the reciprocal. So you usually hear it described as just like flip and multiply. So a division problem, again, division and multiplication are pretty much the same thing. So when you are given a division problem, what it means by flip, that means the second fraction changes. So our first one stays the same. When that second fraction changes from division to multiplication. So flip and multiply means flip the second fraction and then you just multiply them. So once you change it into a multiplication problem, you are going to do exactly what we did before. The example I gave up here, do anything on top and bottom reduce. No, so up top, 2 times 4 is 8. On the bottom, what's 5 times 3? Yeah. So a division problem, you pretty much just cheat the system, write it as a multiplication problem, and then you do the exact same thing. Make sure somewhere on your notes you just have flip and multiply. Okay, 4 more examples. When you guys are ready to turn the page, go ahead and turn the page. All right, so again, your only little note you need is flip and multiply. Once it's multiplying, you follow the exact same rules that you just did on those other examples. Division, they both don't flip. First one stays the same. The second one, just whatever's on the bottom goes up top. Whatever's on top goes to the bottom. Once you flip it, it's now a multiplication problem. Without any plus or minus signs, there's no factoring. Instead, you're just looking to see what can we cancel out. These ones are probably a little bit more confusing because there's lots of different ways you can go about it. Number-wise, you don't need to do all of the numbers at once. You can just look for pairing. So is there a pair of numbers on top and bottom that you know would reduce? 18 and what? Good. What number goes into both 18 and 20? 2. So now this is a 9. This is a 10. Anything else number-wise? 7 and 14. What goes into both 7 and 14? 7. So this is a 1. The 14 is now a 2. If you look at your x's, can our x's reduce? How many are we going to be left with? 1 on top or bottom? 1 on the top because there are more up top. How many y's are we going to be left with? 2 on the bottom because there's more on the bottom. This is where your work might get messy. Just keep track of what you have. So up top we have a 9, an x, and a 2 to give us 18x. On the bottom we have a 10 and a y squared. Whenever you guys are doing these, especially the ones without plus minus signs, just make sure you can't do anything more. Can we break any of these down anymore? Yep, what can the 18 and the 10 both be divided by? 2 again. So we have 9x over 5y squared. I think those ones are the tricky ones when you don't have to factor because you just have to keep yourself organized. The next one, as soon as you see division, just right away rewrite the problem where it's flipped. Because then you're just multiplying it out. So division just means you're going to flip and multiply. Once you have it flipped, go ahead and go through your factoring. Out of those 4 pieces, which one can't be factored? the 7x, so that one is stuck. Underneath it, how do we factor 2x minus 10? Take out a 2, so we get x minus 5. Up top, x squared is x and x. How do you get a plus 30 with a negative 11? Yep, minus 6 minus 5. And then on the bottom right, how do you factor that? Yeah, take out your x. So then we're left with x minus 6. Once you have it all factored, anything on top reduces with anything on the bottom. So what are some things that'll cancel?
X's.
The x's, good. What else? X minus 5s and x minus 6s. Can the 7 and the 2 reduce? No. So up top, the only thing we have left over is the 7. What's left on the bottom? Whenever you guys see a fraction that doesn't have a bottom, or sorry, a number that isn't a fraction, what can you put underneath it? A 1. So to begin with, the 1 is on the bottom, but because this is a division problem, when you flip it, where's that 1 going to move to? To the top. So be careful about your flips. Okay. Starting in the bottom right. How do we factor that? Yeah, good. Only thing is you can take out your GCF, which is an x. The 1 is stuck. The 4x squared is stuck. And then the reason we are doing the top left last is when you guys look at this factoring, is there a GCF to it? No. So this is kind of one of the annoying ones, because in order to get 6x squared, what could your parentheses start with to give you 6x squared? So either 6x and x, or what else could it be? 3x and 2x. Do we have same signs or opposite signs? Opposite. Now, use the problem to help you. Our end goal is to be able to cancel things, and most of these problems you guys are going to be able to cancel things. So if you look at the other parts of this problem, should we try the 6 and the 1 or the 3 and the 2? 3 and 2, because if you guys look down here, do you see how that's a 3x plus 5? Wouldn't it be super helpful if we had another 3x plus 5? So when your factoring gets tricky, look to the other pieces of the problem. Usually you'll be able to use it to kind of help you. So I'm going to try 3x and 2x. Because that's a plus 5, I'm going to let that be the plus 5. Not guaranteed that this is going to work, but this is how you should start. To give us a negative 15, what would the other one have to be if this one is already plus 5? Minus 3. Again, not guaranteed to work, but this is where you guys should start things when you're trying to figure out how to factor it if you're stuck. Because most of the time, if I'm giving you problems to solve, they're going to be factorable. Does this one work out to give us a positive 1 in the middle? Yeah. So when your factoring gets weird, try to use the other parts of your problem to help you. Or you just guess and check. If you didn't think about that, you'd only have so many things to try anyway. Once it's all factored, anything on top can cancel with anything on the bottom. So those are the same. Can we reduce those x's out? No, they're both on the bottom. So up top, we have a 2x minus 3. On the bottom, these two pieces are left over, so we have a 4. And then how many x's do we have on the bottom? 3. All right, last one. When you see a division, which fraction flips? The first one or the second one? Oh, no, I put my parenthesis in the wrong spot. Sorry, because it should have been all in one parenthesis. I just messed up where I put it. Good catch. Starting in the top left, how would we factor that first? negative 1x. So take out your GCF of negative 1x, and then we're left with x plus 3. If you have a negative in the front, take it out. Can we do anything with 9 minus x? Nope, so just leave it. Up top, how do you factor 2x minus 18? Take out a 2, and that leaves us with x minus 9. And then on the bottom, what do we do? Yeah, just take out an x, and then we're left with x squared plus 3. What are some things that cancel? X and x. What's something that looks really close to canceling? Yep, x minus 9 and 9 minus x. From Friday, do you guys remember if they are backwards of each other with a minus sign, they do cancel, but instead of leaving a 1 behind, what are those going to leave behind? A negative 1. So when you have that set up, they do cancel, but they leave behind a negative 1, because technically that 9 minus x, you could factor a negative 1 out of it to make it be the exact same. Can we cancel our x plus 3? Nope, because the other one's an x squared. So up top, we have negative 1. What do two negatives make? Positive 1, and then x plus 3. On the bottom, we just have x squared plus 3. Do you guys have questions on this? Do you see how it's all the same thing?